Hello viewers, I am Manav-Jyoti, Assistant Professor in the Department of Computer Science Engineering of Assam Downtown University. And in this video, I'll talk about the first in first out or Fifo page replacement algorithm. Page replacement is basic to demand paging. It completes the separation between logical memory and physical memory. With this mechanism, an enormous virtual memory can be provided for programmers on a smaller physical memory. There are many different page replacement algorithms. Every operating system probably has its own page replacement scheme. A first in first out replacement algorithm associates with each page the time when that page was brought to memory. When a page must be replaced, the oldest page is chosen. If the recent past is used as an approximation of the near future, then the page that has not been used for the longest period of time can be replaced. Page replacement takes the following approach. If no frame is free, we find one that is not currently being used and free it. We can free a frame by writing its contents to swap space and changing the page table to indicate that the page is no longer in memory. The freed frame can now be used to hold the page for which the process faulted. The page fault service routine is now modified to include page replacement. If no frames are free, two page transfers are required. This situation effectively doubles the page fault service time and will increase the effective access time accordingly. This overhead can be reduced by the use of a modify bit. Each page or frame may have a modify bit associated with it in the hardware. The modify bit for a page is set by the hardware whenever any word or byte in the page is written into, indicating that the page has been modified. When we select a page for replacement, we examine its modify bit. Page replacement is basic to demand paging. We must solve two major problems to implement demand paging. We must develop a frame allocation algorithm and a page replacement algorithm. If we have multiple processes in memory, we must decide how many frames to allocate to each process. Further, when page replacement is required, we must select the frames that are to be replaced. There are many different page replacement or algorithms. We evaluate an algorithm by running it on a particular string of memory references and computing the number of page faults. The string of memory references is called a reference string. We can generate reference strings artificially or by tracing a given system and recording the address of each memory reference. The latter choice produces a large number of data. To reduce the number of data, we note two things. First, for a given page size, we need to consider only the page number, not the entire address. And second, if we have a reference to a page P, then any immediately following references to page P will never cause a page fault. Page P will be in memory after a first reference. The immediately following references will not fault. To determine the number of page faults for a particular reference string and page replacement algorithm, we also need to know the number of page frames available. Obviously, as the number of frames available increases, the number of page faults will decrease. For the reference string considered previously, for example, if we had 3 or more frames, we would have only 3 faults, one fault for the first reference to each page. On the other hand, with only one frame available, we would have a replacement with every reference resulting in 11 faults. The simplest Page replacement algorithm is a Fifo algorithm. A Fifo replacement algorithm associates with each page the time when that page was brought into memory. When a page must be replaced, the oldest page is chosen. It is not strictly necessary to record the time when a page is brought in. We can create a FIFO queue to hold all pages in memory. We replace the page at the head of the queue. When a page is brought into memory, we insert it at the tail of the queue. The FIFO page replacement algorithm is easy to understand and program. However, its performance is not always good. The page replaced may be an initialization module that was used a long time ago and is no longer needed. On the other hand, it could contain a heavily used variable that was initialized early and is in constant use. A bad replacement choice increases the page fault rate and slows process execution but does not cause incorrect execution. The number of falls for 4 frames is greater than the number of falls for 3 frames. This result is more unexpected and is known as Belades anomaly. Belades anomaly reflects the fact that for some page replacement algorithms, the page fault rate may increase as the number of allocated frames increases. We would expect that giving more memory to a process would improve its performance. In some early research, investigators noticed that this assumption was not always true. Belades anomaly was discovered as a result. Thank you.